Hello everyone. Today we're going to be looking at the geometric mean. We want to use the geometric mean when we're looking at the growth rate over time. So we're looking at multiplicative processes as compared to additive processes. If we just take the average rate of change over time, it's not going to be accurate. We have to use a different formula called the geometric mean to get the true average rate of change. And I'll show you an example using the United States CO2 emissions from the period 2001 to 2011. So I got this data from the World Bank, and let's just take a look at it here. So you can see we're at the World Bank website. We're looking at CO2 emissions in KT, which is kilotons. So I'm going to go down to the United States and record the values. This is the value 2011, and we could get more data by clicking on these links. Beginning in 2001, I just recorded the data from the United States and put it into my Excel file, which the values are shown here. So the first step that we take is calculate the rate of change. And the formula commonly taught is by taking the difference of period 2 minus period 1 and dividing it by period 1, 0.84%. I like to use a simpler formula for Excel. There's less calculations to input. So you just take the ratio of the two periods and minus 1. It gives us the same value. Either formula works, so I'll stick with that one, copy it down. And then we need a relative return. So we're going to take that value plus 1, and I'll copy that formula down. And to get the geometric mean, the first step that we have to take is the product of the growth factors. So this relative return is also referred to as a growth factor. So you just multiply each growth factor. And you can push F2 and you can look at the formula. So we have the product of 10 growth factors. The next step we want to take is to take the nth root of that product. So the nth is the number of years that we have. 2001 to 2011 is 11 periods. So we take the nth root of the growth factor. So 0.9472, take the nth root of that. In Excel, we just raise it to 1 over n. So we have 0.9472 raised to the 1 over 11th power. And that gives us 0.995, and this is the geometric mean. So to get the average rate of change, we're going to take the geometric mean minus 1, which gives us negative 0.5%. So let's check our work. If we take the first period and multiply it by the average rate of change, and we do this for each successive period, what I'm expecting to see in 2011 is the actual value. So By applying this constant rate of change over the 11 periods, I should come out with 5,305,570. So let me just copy this formula down, and we could see that our average rate of change of negative half a percent yields us the same ending value as our actual values. So our actual percent change, varies. It looks like it ranges from negative 6.2% to 2.55%. So if we just want to get an average rate of change over time, we look for the geometric mean. Let's just say that we didn't do the geometric mean. Let's just see what the additive percentage gives us. It's pretty close, negative 5.1%. So that's pretty close. In this case, it was pretty close to the geometric mean, but other times it could be pretty far off. So it could be misleading if you took the average rate of change. And this is especially important if you're looking at an investment, the average rate of change. You don't want to be misled. So make sure you're using the geometric mean. Okay, that concludes the geometric mean. Thank you.